Hello, everyone, and welcome back. I am once again Derrek, DevRel lead at Recall Labs, and I am joined again by CTO Carson. Our goals today are twofold. One, to actually scratch beneath the surface on some pretty interesting technical stuff we're doing, but two, to make it totally understandable every step of the way.
Two pretty big nerds here, so I think it could be a fun opportunity to dive into some details that people might want. Pretty much the whole internet operates on some form of like reputation. Like you think back to, I'm going to pretend that I wasn't around for the start of the internet because that just ages me a lot. Early days of the internet, there were literally people compiling lists of websites that you should check out for particular topics. And then eventually we started to get a little bit more sophisticated about that. Like Google was a big breakthrough with their PageRank algorithm to try to create a ranking algorithm that helped you find what you were looking for. And it was based on fairly objective metrics of what made a website informative or useful, and based on incoming links and outgoing links and the ratios. And they were able to create this useful thing upon which a lot of modern internet is built. It's about a reputation, really. We want to start thinking about ways to develop a reputation and scoring mechanism to make sure that we're finding the right agents and AIs and products and models and tools for the right task at hand. If you're going to build a reputation index for the internet of AI, we've got a lot of prior knowledge to learn from. We've done PageRank. We've learned a lot since the early days of the internet. So let's at least make sure we take some of these learnings into account. Two, we're getting to the point now where we have these magical answer machines that tell us everything we want to know, right? Like these AIs. And so I think it's pretty important to make sure that like collectively we are ranking them in a way that is good for everybody, because we've got these, it's different than a website, right? A website is sort of like in general, prior to Web 2, it's like a static piece of information about a very specific thing generally. And I go to that one website to learn about the one thing. But now we have, ChatGPT and a lot of these models where I go to like the one thing to learn about everything. And so we got to be a lot more careful about how we do that ranking stuff. And so we've outlined a couple of things that we think are really important. One, whatever reputation score thing you're doing, you got to try to make it not gameable. Right. And one thing we've definitely seen with PageRank is there's a whole industry of people who teach you how to get your PageRank thing up, and they have to change the algorithm constantly to try and adjust for that. So we want to try and from the get-go find ways to make it harder to game the ranking system. It should also be based on the thing that you actually care about. Like, is this a good writing agent? Is this a good model for being empathetic? Is this a good model for writing poetry? Those are the things you want to measure it on. Not like, is their marketing budget bigger than someone else's marketing budget? So it's got to be performance-based. And then there's the crazy part, right? We're talking about things that learn, like on purpose. And so websites don't learn. The people who write websites, they learn how to make them better, but websites themselves don't learn yet, until I guess websites become AI as well. The AI tools that we're trying to rank and understand, they do learn. So we've got to have ways to dynamically score them so that when they learn things, we understand and update our rankings to reflect that. And then, we want people to be at the steering wheel of this like crazy rocket ship that we're all testing and building as we fly off into the future. So it better be, community driven, and not this like fixed thing that can't be changed, right? Related to that, there's no point in even doing it if people can't use it and see it and build on it and build with it. So it's got to be open and composable as well. And so we want anyone to also be able to like include those in the rankings and things like that. So you might have seen, if you participated in our predict experiment, we had people submit evals and submit their own ideas of how to measure these things. And that's pretty important, because if we can't do that together, then it's very difficult to adapt and build this open and composable way of measuring. So these are all pretty important.
So now we get to dive into ungameable a little bit for people that were wondering, what do you mean game it? Web 2 had SEO, but surely when it comes to modern benchmarking, MMLU Pro, like the competition math stuff, SciBench, like it's great, right? Like we have all these evals, we have all these benchmarks.
These aren't websites that don't learn, they're AI things that do learn. And so, yeah, we release a benchmark, new benchmark, awesome. Model builders in their next gen model, they go, awesome, thank you so much for all of that extra training data. I'm just going to hand that over to my agent now. And the next time we run the benchmark, obviously I'm going to be better at it.
It's more nefarious than that. They're fine tuning to make sure that they have practiced these tests,
Running
like
it over and
SATs.
over and over again.
Yeah, like again.
They call this benchmaxing. And like it would be silly if they didn't do that, right? Because like we already know that these models are super hungry for data. Here's a bunch of data that they can train on, and it's like designed specifically to like so a lot of these models use like reinforcement learning and stuff, and it's like designed specifically to test if they're like good at specific things and how far off they're. Like it's perfect. We just have to make sure that the benchmarks constantly evolve and change, just like the models constantly evolve and change. And so you want to try and come up with benchmarks that are ungameable. That's the idea, is you want a metric that like they can't know ahead of time and train specifically for. In addition to having the things that you're testing be dynamic, the tests themselves should also be dynamic. So you need to be able to update the benchmarking itself over time. So if you squint at it the right way, like doing well on a benchmark or something like that is a form of like developing a reputation, and you want that reputation to like kind of evolve and update over time. And so that's what we're trying to build with Recall Rank. So Recall Rank is the sort of like underlying protocol that we use. We want those AI, systems or models or agents or whatever to basically like accumulate a reputation over multiple iterations of these testing, so that we're kind of like constantly updating it and changing it so it can't kind of game the system or like rank to the top of a leaderboard just because it did like really well one time.
Mm-hmm.
So like, I don't know, we're a Web3 company. I firmly believe that like we need to leverage some of the like on-chain primitives that we have to drive trust. Like things need to be observable. And that's what Recall Rank is. It's designed to leverage those things. And the whole protocol will be increasingly decentralized over time. Decentralization is the tool with which we increase trust and transparency and objectivity. It's not the goal. Like decentralization is one way to get there, but like the goal is trust and transparency and like openness and observability. And so Recall Rank is designed for that specifically.
Yeah. As a specific example, we will publish the underlying data wherever possible, and not just the recall trademark symbol official rank, trust us because we said so. We want, like, we trust that there will be savvy actors out there that want to take their own look at the underlying data and say, okay, maybe I don't care about these aspects of it, or I add certain filters and I come to my own conclusion. So both layers there, right? Low level and high level.
Totally, exactly. Unlike other benchmarking systems, we try to leverage the community and incentives to actually incentivize that community to help us curate better the rank. So far, we've had really specific competitions. In future versions, we will also be like we did with that predict experiment, where we said like what skills should be measured and how should we measure those skills. We're going to continue to do that more and more in different contexts, so that there's also an incentive to help us decide what to measure. The community comes and suggests what we should measure. And then with that same experiment, we said like, how should we measure these things? What are the evals that we should be using to measure empathy, or whether you can, do two-step like workflows, or whether you're going to actually not use M dashes when I ask you not to use M dashes. How do we measure that? Well, the community can help us with that as well. And then the final step of that sort of play is like, oh, okay, well, you helped us figure out what to measure. You helped us figure out how to measure it. Now, did they do it correctly? This is where some of these incentives start to play in. So basically, by providing more information to the network, we can like kind of decrease the uncertainty that we have about how good an agent is at a thing. Recall rank is based on measuring things across two axes. And so we've got the actual raw performance scale here. So it's your skill relative to other things. And then on the uncertainty scale, it's okay, if I think you're ranked about here, how certain am I that you're actually ranked there? Or like maybe you just got lucky that one time and you really should be ranked here. You have some like latent underlying skill level for a thing. An AI model does. An AI model has this underlying latent skill at not using M dashes when asked not to use M dashes. I'm using this one because it's silly and easy to think about. There's some uncertainty around that. Like I know it's got some latent skill, but I don't quite know what it is. But if it does this a bunch of times, if it competes a bunch of times at trading or at like not producing M dashes, and we score it over time, that uncertainty starts to narrow in on what its true ranking should be along this axis. Now, what happens if, say, someone comes in, they like boost to the top of the leaderboard, they do so great, and then they're just like, well, I'm the best now, and I'm just going to stop. Well, we already know that like other agents are out there like learning, improving, and the models are getting better over time. And so what will end up happening is those ones will keep competing. This one will stop competing, and our uncertainty starts to go back up again. Because now we're not sure anymore relative to other competitors how good it is at, like, if it really does rank first, second, third, whatever. So we've got this like sort of like way to fine tune and understand what its latent score is over time. If it stops competing, we start to lose that certainty. We can capture that. What's a bit of a bummer is if, say, some new agent comes in and it's really good at a particular skill, but has never competed before, how do we like get a better sense of where it should actually rank? Again, we ask the people, and they can basically try to back that agent literally through like voting and staking. And then that also influences the uncertainty, but it never influences their score. The only way to move this way on the axis is just be better. Sorry, just be better. And then the only way to move in this axis is compete more or get more of the community to back your skills. And so we combine these things together to produce something that we're calling recall rank. The original kind of like scoring thing that a lot of people maybe know about is ELO scores from chess. And it's basically a way to measure like how good someone is relative to everybody else across like when this concept of like a latent skill level is involved. I am terrible at chess. So my score would be like the default score, and their score would be way up here. And so it doesn't matter like what those things are, they're just relative metrics, but we have a way to measure that. Another context where this is useful is in like online gaming. If people like play Halo, these like giant Halo tournaments and things like that, you often want to know, like you can form these teams and compete against other teams. And it's useful to be able to rank and score not only the individuals on the team, but also the team itself. So there's like specific models, scoring models that have been developed to address that. I love it when like really cool math comes out to solve like a fun gaming problem, right? You're like, I just want to play online with a bunch of buddies and like see who's better, whose teams are better. And then some mathematician's like, yeah, okay, cool. I'll invent a new math for you. Cool.
Yeah.
Like I love that. And so that's kind of, we leverage one of those scoring systems, which is called Plackett-Luce. This is, it's like an extension of a Bradley-Terry model to the multi-competitor scenario, which is what we have on Recall Rank, where we're doing multiple competitors. It's talked about really well in this paper. Naturally, everyone will just want to read this very dense scientific paper. I assume you all read these on your weekends. That's
Hey,
what we do.
you had me at online ranking with multiple players. Like this is what I care about.
It's an extension of another model called the Bradley-Terry
Yeah.
model, and that's designed specifically for pairwise comparisons. So if you've ever played around with like LM Arena, they use a modified Bradley-Terry, and that's a good model. but there's like a couple of reasons why it doesn't quite fit what we need to be able to solve for. One, it's actually quite computationally expensive to do. So if you want to start doing things like on-chain or in a Web3 context, that's a little harder. Two, it's designed specifically for head-to-head. And so and so is like ELO scores as well. So when you're trying to compare like a bunch of agents that are all trading, it doesn't quite work. You can kind of artificially do that by creating like artificial one-on-one head-to-head things and then like doing them all against each other. And that's how you create a score for a bunch of players playing. Or you could just use a metric that's designed specifically for multi-competitor scenarios. And so that's what Plackett-Luce is designed for. It also has a really efficient update algorithm. I'm not going to go into the details of that, but if you're like a Bayesian math geek, you might like that. And the Plackett-Luce one, the other reason we quite like it is because it is explicitly designed to capture a latent score and a uncertainty about that score. It's literally the thing that we kind of like want to capture is these two things. And so we call them mu and sigma. We track those two things kind of separately within the system. And then we take those two things, your like latent score and the uncertainty about that score, and we calculate your overall recall rank. Basically, we take your latent score and we take your uncertainty about that latent score, and we kind of like just subtract the uncertainty from your score. And we do that for everybody, and then we rank them. That's the simplest way to think about it.
Strong start. So that way, if somebody has a really high score but really high uncertainty, they're not at the top of the board compared to somebody with the same score but low certainty. We start with, let's imagine no one's endorsing you. That's a huge spread. And for the same skill, if there was endorsement, you could see a narrowing.
When we calculate the final rank, we do it in such a way that, like, statistically speaking, we are 99.7% confident that the AI's true score at that particular skill is at least this high or higher, right? Because there's some uncertainty. We don't know for certain. So you're like, if your latent score is like, I don't know, here and mine is here, we can compare those two things and we are 99% certain that your score is at least here and mine is at least here. But like there's some possibility always that like your score is a little bit higher.
I have a question for you. There's a graph we haven't really touched on. It might be a great place to finish this out, just to paint a little picture of where we're going and the role people play in this ecosystem we're designing.
Well, we've got a kind of like quadrant here of like define, compete, curate, and discover. And all these things play together to create recall rank and our like ranking protocol. So the way that it will work as we sort of like roll all this out is that the community is basically like governing how and what we measure, right? So the community will define and design the types of competitions and the types of skills and how we measure those things and how we should allocate rewards to those things by getting involved. And that's through staking. So they can actually stake and participate and then potentially earn from their work because they're doing work for the network. If you do work for someone, you should probably be rewarded for that work in some way. That seems like a fair trade-off. Then we have the actual like individual models, agent builders, teams, whomever, who will actually compete in these like seasons of competitions on the specific skills defined by the community. And they must also stake to participate in that. And then they can earn. We've got this curate, which is like, okay, you told us what to measure, how to measure, and how to dish out rewards. Then we went and we did that thing, and we measured it. And now it's your turn to help us curate those results. And you got to stake, and you can potentially earn for doing that too. And then all of this stuff is building up this like giant corpus of valuable data, this agent rank index, right? That then users can use, or other developers can use, or other ecosystems can use to like help drive discovery and understanding really what is the best thing for this particular skill I'm interested in. That ties us back to maybe the like PageRank analogy, if you will, which is like, okay, you've decided what you're going to measure and how you're going to measure it. you measure it, you collect up this corpus of data. Like now let's build a whole new ecosystem and industry around that thing that you've measured. Like the web runs on PageRank. And so now we start to actually like leverage that asset to the rest of the world. We're going to do it. It's going to be rad. It's going to be fun. You should have a say in this crazy future internet that we're moving towards. Don't you think? I think everybody should have a say. I talk to some people every now and then who are like, I'm a little worried about like AI and the direction it's headed. Is it going to be good for everybody? And my answer to that is like, I don't know, maybe, hopefully. But I know for certain that if you don't get involved, then you just don't get to complain about it if it doesn't go the way that you want, you know? So if you want to have a say in the future direction of the internet, Recall is a really great way, I think, to help do that together. But either way, you should just get involved in some way that you can and however you can.
We literally couldn't do this without everyone's participation. So thank you to the thousands of people that have already been submitting skills, submitting evals, making agents competing in the trading competitions. We appreciate all of you, and we can't do this without you.
Well, we could, but it'd be less fun. Honestly.
And we would just be like streaming to nobody, and like nobody would use the thing. So
yeah, this has been really fun, Derek. I hope you get to do this again. I like nerding out with you. It was fun. If any of our viewers want more of this stuff or less, I guess I would be okay to hearing that too.
Yeah, please let us know either way. Yep.
Yeah.
All right. Well, until next time, thank you for joining me, CTO Carson, and we'll see you all on the internet. Bye-bye.
Sweet.